Hey everybody. As per request, I know a lot of people had some difficulty with some of the procedures of this lab. I originally did not intend to record anything with regard to it, but because popular request has asked me to, I'm going to do a quick little tutorial on how to get the graphs done in this density and graphing lab, which was originally, it was originally lab number 2. So if you guys have not already given this in because you're having some issues with the graphing part of this, hopefully this video helps. So most of you guys got this first procedure done. The first procedure asked you to, using the data table below, plot the mass and volume of each of the samples. There were 5 samples in total. Each sample, 1, 2, 3, 4, and 5, had a given mass and volume. And using that mass and volume on the very first graph, it should say procedure C here. So the graph itself here, you were supposed to label or continue to label your mass and your volume axes. I kind of started them for you, but I wanted you to continue. And it would be a good idea to label these, continue to label these before you actually go to plotting. If you'll notice here, the interval for each line goes up by 2.5. This one stops here at 25. If you skip a line, this would actually be 27.5, but this would be 30. And if you skip a line here, this would be 35. And again, you don't need to go up exactly by 2.5 for each, but if you label every other line going up by interval of 5, it kind of gives you the basis for what you need to be able to plot this. Now, the y-axis here, which is your mass, it does go up at a slightly nicer interval of 20s. So 0, 20, 40, 60, 80, 100, 120, 140, and so on. So on this first graph, what you were supposed to do, if we look back at the data, is you were supposed to plot, okay, the mass and volume using these 2 coordinates, your mass being your y-axis and your volume being your x-axis. If you plot the coordinates, like for instance, sample number 1 had a mass of 15 and a volume of 2. If you go back to your graph, right, a mass of 15, right, so this is 0, this is 20. 15 is going to be a little bit more than halfway, so 15 would be about in here, and a volume of 2. This first line is 2.5, so a little bit to the left is going to be your first plotted point. So you're going to connect into that first plotted point, and then you can go back. I always tell you guys that I kind of like to keep a record of like what I'm doing by kind of crossing it off or putting a check mark to make sure I did it. And then you go to sample 2. Sample 2 had a mass of 60 and a volume of 8. So again, if we go back here and we look at our mass and our volume, 60 was your mass. So here's 60 right here, and we're going to come into a volume of 8. Now this would be 7.5, so 8 probably be about there. So 60 and 8. So that's your second plotted point. You're obviously going to connect as you go. And then we come back here and we look at your third plotted point. So I did that. It's 120 and 16. So again, we come back to our graph. We go to 120 and 16. So again, this is 120 here. Come in from 120 and 16 would be just past the 15. So your third point would be here. Now, that's 3 example points for you. You should be going back to your data at this point and obviously continuing to plot your 4th and 5th sample. Once you're done with that, that's procedure 1. Procedure 2 here asks you to calculate the density for each sample. This is no trick. If you do mass divided by volume, which is how we do density, each one of these is going to come out to being the same exact density. Because if you do read pretty carefully, it says that each one of these samples here in procedure 1, direction number 1, each procedure is of the same mineral. It's all galena. So no matter what the size of that piece of galena is, the density ends up coming out the same for each time you do mass divided by volume. So again, 15 divided by 2 gives you a certain density. You're supposed to divide them. And then you're supposed to do 60 divided by 8, 120 divided by 16, and so on. Okay, that again will give you all the same densities. So once you do that, your procedure number 2 is done, which brings you over to some questions. And it says, using the completed graph above, Determine how much mass a sample of galena would have if it had a volume of 75. So you're supposed to use your graph that you completed. Sorry, I keep going the wrong way. And once you complete that graph, okay, and you connected all your points, you're supposed to use what they're asking you to do. So again, if it says in the question, if I kind of scroll back to that question and just reread it one more time, it says you have a volume of 75. What is the mass? So again, you go to your graph, you would go over to a volume of 75. So like this is 35, this would be 40, 45, 50, 55, 60, 65, 70, okay, and I think it said 75. So we'd start somewhere on this line. Again, we're starting from the volume, which is down at the x-axis, and now you've created a graph. By doing those other points, you should have a line that's going straight across the graph, right? Well, at that point, what you do is you go to that 75 for that volume, whatever they tell you to go to, and you're going to go straight up on that line, all the way up until you hit the line that you created. Once you hit that, you're going to come out to the left here and you're going to have a mass. Okay, again, it helps to have your axes actually labeled before doing this. Okay, now when you get to the next question, question number 2, it says using the completed graph above, determine how much volume of a sample of galena would have with a mass of 300. Okay, now it's kind of done the same way, but in an inverse kind of thing. Here's 200, 220, 230, 220, 240, 260, 280. 300 would be on this line. You would go from a mass of 300, right? Once you get to this 300, again, I'm starting here for the mass. You would come in, hit your plotted line, and go down and give me your volume reading. Okay, so that's questions 1 and 2. Question 3, it says describe the relationship between mass and volume. Guys, anytime you have a line going up on the right, it is a direct relationship, okay? Number 4, how does the density of sample 2 compare to sample 4? So you are comparing your data chart, the density of sample 2, which is done by mass divided by volume, compared to that of 4. Okay, and then your last question, which is question 5, how does the density of the largest sample 5 compare to that to the smallest? Again, you're comparing the density on the graph of the largest piece, so whatever you figured out the density to be, as compared to that, what you figured out the density of the smallest piece to be. Okay, so that clears up that procedure. The second procedure is super, super, super easy. I find this to be the easiest procedure because it's kind of like tangible. You can look at the object. Each object is given a mass, and then you take your length, height, and width, and you multiply them to get a volume. So like for the first cube, they want you to find the density. With a mass of 10, which I wrote over here, 10 grams, right? And a volume, which I figured out to be 0.8 times 0.8 times 0.8, gives you 0.5 when you round it, a cubic, 0.5 cubic centimeters. If you do 10 divided by 0.5, it gives you your density of 20. So this first one was done for you. You go on to doing the second one. So again, mass of this equals 30, it says it, and then you have to do 1 times 1.8 times 0.5 to get your volume, and whatever you get your volume to be, you divide that 30 by your volume, okay? Then you go on to follow the same steps for this and that, same steps. All they want to do is take your mass, divide it by your volume, which you get by doing length times width times height. Okay, and then again, your density goes over there. Now, this is the part of the lab that really start to like get people a little confused. And if you read the directions, it says, determine the density, you may use the space below to show your work. Okay. When you look at object A, you got 4 samples of the same object. And they keep on giving you masses and volumes. All you literally have to do is pick one of the samples for volume A, and you would have to do the mass. In this case, it would be 16 divided by 32. Not 32 divided by 16, but 16 divided by 32. And when you do that, it's 0.5 grams per cubic centimeter. And again, this one you would do 24 divided by 32 to get your density, 4 divided by 4, which is obviously 1 to get your density, 16 divided by 16 divided by 8, which is 2, and then again, mass divided by volume, 32 divided by 8 to get your density. Now, in this last column, they ask you about sink or float, and they mean if this object, given its density, was put in water, whether it would sink or float. Well, what we know about water is if we take a cup of water, right, water has a density of 1. So in the first example, when you do 16 divided by 32 to get you 0.5, that is less than 1. And anything that has a density less than 1 is going to float. So I'll put an F there for float, or write out the word float. Whereas like something like this, if you do 32 divided by 8, mass divided by volume gives you a density of 4 grams per cubic centimeter, right? Obviously this is greater than 1, so whatever this object is, which they're not telling you, if it was put into water, which has a density of 1, it's going to sink. So when you figure out the density, less than 1 floats, greater than 1 sinks. If it's equal to 1, it will most likely be suspended within there and be floating, not sinking. Okay, that brings us to the final part of this lab, which again, this is probably why I'm making this video, because a lot of you guys got the first part of this, but the last part of this was really quite confusing for some of you, and that's okay. This is how we learn. We usually get a little confusion point, we kind of power through, show a little grit and tenacity, and then all of a sudden we get things. So here we go. The last part of this lab says, using the data table below and the graph for procedure 3, plot the mass and volume of the 5 objects. Note, the resulting line you plot is the object's density. Plot the mass, gram, on the y-axis using intervals of 1. Plot the volume on the x-axis using intervals of 1 cubic centimeter. Connect the points. You can use a different colored pencil for each object, but don't forget to make a key. So we're going to start with object A. And you got to look at object A only as object A when plotting. Forget about B, C, D, or E. We're going to look at object A. And we got 4 points to plot. The first one's going to be a mass of 2 and 4, then a mass of 2 and a volume of 4, then a mass of 4 and a volume of 8, a mass of 8 and a volume of 16, and we're going to plot then 16 and 32. So 2 and 4. If I go to my procedure C graph, or procedure 3 graph, okay, my mass is found here, so I'll put an M for mass. Obviously you can see the volume. The first plotted point was supposed to be 2 for mass and 4. So if I go from 2 for mass and up from 4, here's my first dot. You can connect in from 0 for this, right? And then if I go back to my data, right, the next thing said plot 4 and 8. So if I plot 4 and 8, right, a mass of 4 and a volume of 8 would end up coming out as your second dot here. And again, connect. And then you go back and you're like, okay, got that. Do 8 and 16. So again, 8 would be on a mass, 5, 6, 7, 8. This is 8. 16 would be 11, 12, 13, 14, 15, 16. I'm coming up from this line. I'm coming in from that one. This is your 8 and 16. And then I think the last one was 16 and 32. So 16 for your mass, 10, 11, 12, 13, 14, 15, 16. And 32, this is 30, 31, 32. So I'm going to come up from this line, and I'm going to come in all the way up here. I believe that's the right one. And you're going to connect in. Let's see if I can use my pen instead of my cursor. But you're going to connect in. Obviously, it's straight line. When you're done, okay, if you don't have colored pencils, you legit could just do object A. If you have colored pencils, you can make a little key and just say this is object A, right? And then you go to object B. Now, go back to your data. Object B is this one. Let's change the color of this. Okay, we'll make this green. Object B says your data is starting with the mass of 3 and a volume of 4. So if I go down, my mass of 3, let's see, 0, 1, 2, 3, and a volume of 4, which is here. Okay, I'm going to connect in from 0. I'm going to connect. And then I go back, and now I'm going to be plotting these, 6 and 8. So go down, a mass of 6. Oops, sorry. Back up again. A mass of 6 and a volume of 8. Come on up. There's my second plotted point. Okay, I'm going to go back up to my data, and then I do 12 and 16. So again, come on down, a mass of 12, let's see, 10, 11, 12, right here, and 16, let's see, 10, 11, 12, 13, 14, 15, 16. So I'm going to come up, coming in from this line right here, And again, I'm going to connect in from that last point, right? And then you got one more, and the last one's going to be 24 and 32. So 24 and 32 on this one would be, let's see, ready? 21, 2, 3, 21, 22, 23, 24, and 32, 31, 32. So I'm going to come all the way up here. I'm going to come in from right about there. And again, I'm going to connect into my line. And once again, if you have a different colored pencil, you could say on your key that this was object B. If you don't, you literally can just like label the line object B. So I plotted the first two. Now that you have an understanding of this, you're going to go back. You can plot, okay, perhaps with different colored pencils if you have them. If not, with whatever you want to do. But you're going to have to plot the coordinates, 4 points for object C, the coordinates for object D, and the coordinates for object E. And again, when you're done with this graph, you're going to see 5 lines in total. I did 2. You have 3 more to plot. I believe one of the lines is very, very short in here, and the other ones extend a bit more. So hopefully that clears up what questions you had on this lab. And those of you who have not submitted now have no reason not to. You can use this video for your assistance. And of course, remember, quality work over quantity. Even if this lab is 2.5, 3 weeks late, I'm not concerned with that. I want you to do well, I want you to learn, and I want quality work to be handed in. Okay, so that's about it, guys. Hopefully this helps.